Hello, my name is Fredrik Oberg. I'm a consultant anesthetist and intensive care doctor at Karolinska Hospital, and I'm going to talk to you about healthcare data and the Origo platform. And let's start with some background. This is an EMR system, an electronic medical record system. It has some internal logic, which means that it does something. It also stores data about patients, and it's got some kind of user interface. A generic IT system. The problem is that data about a single patient is spread out and stored in many such systems. Each caregiver tends to have their own one, and even within a caregiver's organization there can be several. So when I receive a patient from another hospital's ICU to my ICU intensive care unit at Karolinska, it's empty here in my system, so I have to enter lots of data manually about the patient. Information doesn't follow the patient because it's literally trapped inside all these systems. This is a well-known problem for healthcare professionals and researchers and people trying to do follow-up and analysis. It's not so well known to patients, luckily. There are solutions for sharing some predefined datasets between systems, for example X-rays, lab results and patient summaries. You'll find lots of them if you start looking, not least internationally. But this is not enough, because we need to share all data recorded about a patient between caregivers and for research and with the patient in a secure and controlled way, respecting the integrity and preferences of the individual. How can we achieve that? Well, interoperability. The systems should talk to each other. This is a standard answer, not least among politicians. So if you've got an entry here in this systems database that represents something in the real world, let's say the patient's weight, then if you got a field in this database also representing weight, then you could send this figure over to this system, so these guys don't have to weigh their patient when the patient arrives from here, this other hospital. This is a classic systems integration. It's pretty hard work though to set this up. I actually led such a project a couple of years ago, and it took us almost 2 years to agree which parameters we could send over from one system to the other. It was some 20 parameters involved, and we had actually to skip the parameter blood pressure because we realized we didn't mean the same thing with this in our systems, so it wouldn't have been safe for patients to send it over. Okay, so how can we get around this problem? A common answer to that question is that we should have some kind of terminology standard. This means that you have a catalog of medical concepts and terminology in your system. And when you store this figure 75 in some field in the database, you would also store a reference to this definition in the terminology standard. And then if you've got the exact same catalog here in this other system, you could let your data flow freely between systems because you'd know what the data stands for in the real world thanks to this reference. This whole idea is sometimes referred to as semantic interoperability. But for this to work, you need some organization, of course, setting this standard up and pushing it out into all these systems, including regular updates. And you need all systems to be connected to each other in some way. Perhaps by an external system acting as a hub for shuffling data between systems, and there could be some data storage in the hub too, of course. I won't go into detail here. Now, there are some problems with this approach. The first one I like to call the ontology problem. The fact is there is no complete terminology standard around. The largest one is SNOMED CT, covers some 30% of all medical terms we use. And also we need lots of non-medical terms if we want to define healthcare data, such as by what device a measurement was made, etc., or by whom. All this is usually referred to as metadata, not defined in the standard. The second problem I call the ad hoc problem, because suppose there were a complete terminology system, then it wouldn't be long before some new concept appeared that we need to record about our patients. It's not in the standard though, but we need to record it, so we'll invent some ad hoc solutions at our hospital in our system to enter this data. And interoperability breaks down, of course. If you're an enthusiast, you might apply for this new concept to be included in the standard, but this will probably take a year or two, which is the third problem here, the lag behind of the standard. And then you'd have to make sure this new version of the standard was distributed and implemented in each and every system out here to get this standard or this interoperability to continue to work. And for each of these systems you'd have to make updates of the system logic as well to handle the new concept. An immense workload and something that just doesn't happen, of course. And this shuffling of data would create multiple copies in the system. And how would you keep track of which one is the true weight of the patient? Should you, for every parameter, point to one of all these systems to serve as a system of record for that parameter? And what happens in that case if the patient is weighed somewhere else? Should they have writing permissions from their system into that other system of record for that parameter? It's obviously not doable to keep track of all this. And imagine the vulnerability of all this when systems go down or disappear because a new system was bought somewhere. And how on earth could you handle permissions to take part of patients' data from another system in another organization if you want to do this nationally or even worse across country borders? And also security would be equal to the least secure of all these systems, of course. And there's obvious bandwidth problems too if you should rely on this for operational data in real time. So let's lump all these problems together and call them the chaos problem of semantic interoperability. One thing you can do is to create a system for external data storage. The Swedish quality registries are examples of this, and Estonia's, well, they've got the famous X-Road, where patient summaries and some other pieces of information from the EMR systems are collected and then shared between caregivers in this way. But even here, of course, you'll have to agree, like when you build systems integrations, on what data you will send to this storage and the exact meaning of all the parameters you send there. And this is very hard work to do nationally with lots of different caregivers involved. So you won't have all data by far. You'll have something like this. And no matter how much you try to keep order here, there will be differences between caregivers in the meaning of the parameters reported, which means that there are some dangers in using these data. And also, this approach isn't very future-proof, which this COVID-19 situation is a very good example of today, because it turns out now that there is no data in the quality registries that is of much help in trying to understand this new disease. You can never know beforehand what data will be of interest for research in the future, of course. So again, you need all data. All these problems have led some people to suggest that we should have one EMR system for, say, all healthcare in the whole of Sweden. But that's not a very good idea for several reasons. I leave it to you to list some problems with that approach. And by the way, why just Sweden? Shouldn't healthcare data be available across country borders? But how about this then? A single storage for all healthcare related data in Sweden, for example. Then each patient would have all her data in one place, and the systems would just be windows to this common information. You could have personal ownership of data here, where the patient could set permissions to share her data between caregivers or for research. And also, it would be quite easy to change systems with this architecture, because patient data would not go away in the changer system. So, why doesn't this exist then? Well, there would be legal problems, of course, but those could probably be overcome by new legislation. But you'd also have kind of a big brother problem and a vulnerability problem too, because this will be a huge database of very sensitive information. But even more importantly, you would still have the ontology problem here, because if you start with this and move these databases down here, you'd have to set up some kind of interoperability inside this database, because data from different systems would be stored quite differently. So more or less you would end up with a chaos problem inside this structure, which is in fact a kind of data lake, and the problem of chaos in data lakes is actually well known. Now let's switch to the Origo platform, which we claim could be a solution to all the above problems, and a quite simple one too once you have set it up. The Origo platform is a non-profit, open source infrastructure for describing, storing and processing digitalized knowledge and data. And to describe its basic properties, I'll start again with these generic IT systems. The Origo platform consists of a network of Origo nodes. Each node is a software that can run in any environment, for example in a smartphone or on a large server in the cloud or inside a caregiver's organization. There is no central node in the platform. Each node is built around something we call a meta-ontology. And now what is that? What is an ontology? This is a mug. But suppose you didn't know that. Suppose that the concept of a mug was completely unknown to you. Then I would have to explain it, or rather define it actually. It's a cylinder, I might say, made of some material, etc. Like this. So by combining concepts already known, I created a new concept here, and I will add terminology as well for different contexts. And this is an ontology, because an ontology is a description of the world. That's what the word ontology means. And there are lots of ontologies around actually. Galileo's model of the universe is one example. The timetable of the metro would be another one actually, rather limited, of course. And to program a computer you must always have some ontology. It is very often implicit, but it's always there, because the things inside the computer must represent something in the real world. This is obvious, of course, but something you don't think much about. But what exactly did I just use to describe this mug? Well, I used language, didn't I? And natural language is quite fascinating, because using it you can describe any ontology. But language is not an ontology in itself, of course. It's sort of empty. It is something above ontologies, something you can use to create them, a meta-ontology. And this is what the Origo meta-ontology is too, in the digital domain. It allows you to create and describe digitalized ontologies, or computer ontologies if you want, in a uniform way. And this meta-ontology is actually the main innovation between the Origo platform. It is analogous to natural language, but in Origo it is impossible to create contradictions or circle references, which is crucial if you want to use it in a computer. And we have good reasons to think that every known digital ontology can be expressed using the Origo meta-ontology. You can describe not only physical objects, but abstract entities and events and processes as well. And everything you describe will be stored in the Origo node in computer executable format, which means that you can't just describe a process, but also run it or execute it in the node. When you store data in an Origo node, you always store it as an instance of a concept definition, or an occurrence of that concept if you wish. For example, to store blood pressure, you store a figure together with a reference to the definition of blood pressure in the meta-ontology. And you will always, of course, have a reference to the individual having that blood pressure too. So you'll have to handle digital identities in this platform. which is quite straightforward, because a person in the real world would be represented here by an instance of the definition of a human being. So existing IT systems can store their data in an Origo node, export them there if you want, and if there is an ontology in the, or data catalog in the system, you can describe that one in the Origo node, so you will not have any information loss at all. And because of the completeness of the meta ontology, you could actually describe your data more fully in the node than in the original system. You could add information about what device, what use taken that blood pressure, by whom, in what situation, or for what purpose, and how the measurement was made. This is what you normally would call metadata. In the Origo node, there is no difference between metadata and data. An example here is the handling of legacy data, which is data in an old IT system when you want to replace it by a new one. Several large procurements of new EMR systems are underway right now in Sweden, and how to take care of all these legacy data is a huge problem in each of these procurements. This works in both ways, of course, so you can retrieve data from the Origo node as well, and this can run in real time. So you can get rid of the system's own database and store all data in the Origo node. It would be easier, cheaper, and a strategic choice architecture for the organization as well, of course, because it would make a future change of systems much easier, and the legacy data problem would go away. And the Origo node has a UX, user interface, of its own, and I'll get back to that later. There are more systems and more Origo nodes, and all nodes are connected to each other in a network, and this network is the Origo platform. There could be millions or billions of them. An Origo node could serve more than one system, of course, in the cloud or locally. Now, these concept definitions will, as a rule, be freely and immediately available in all nodes and for every user globally across the entire platform, once they are created somewhere. So if someone, in order to store data about patients, defines what is meant by, for example, having diabetes type 1, this definition can immediately be used by all other users, if they think it's a good one, of course. I'll get back to that. Let's expand the platform here to show some definitions and instances. Any user can create a concept definition in the Origo platform, anyone actually. And when you do that, you will start by already existing concepts and make specializations or combinations of them, or create completely new ones. In this way, you will build a structure of concepts and their relations. And you do this together with all other users of the Origo platform globally, in collaboration, so to speak. And then by making instances, each with a unique digital identity, you represent things in the physical world. And as I mentioned, abstract entities can be represented too, and events and processes, which is very important. So you can describe exactly how a measurement was made, or the process of diagnosing diabetes, for example. And this multi-hierarchical structure of concepts and instances will actually represent knowledge, if you come to think about it. There's much more to say about this digitalization of knowledge. I won't go any further into that, but an obvious use of it is, of course, as a basis for decision support applications. When you store data in an Origo node, you will have to specify a consent to exactly what can be done with that data. And this is a core function that actually controls the code execution in the Origo node. And therefore, access to and handling of data is technically impossible if it violates any of these consents. Because all nodes are connected to each other, so data stored in one node will be available to all other users from any node in the entire platform, but only if there is consent. These consents can be set at the lowest level or detail or granularity, So you can specify that some data shall be available to only one individual user in a specified context for certain purposes within a certain organization and so on if you want. But these low-level granular consents can be combined into higher-level consents, such as some data should be freely available to all registered healthcare providers in Sweden. And consents can also be constituents of agreements between parties. And just like consents, these agreements will be technically impossible to break. But an obvious question here, of course, is who controls this sharing of data? Who will set all these consents and agreements? And that's the question of data ownership. When you store data in the Origo platform, all data points will always have a data owner. This will typically be the individual that the data is about, for example, the patient who was diagnosed with diabetes. And the data owner will be able to set consents about her data and thus control how it can be shared and used by others. But exactly like in the real world, the power of the data owner will not be unlimited. For example, if you've got a car in the real world, you can't do whatever you want with it. And there are some things that you have to do, like taking it for inspection once a year, for example. And such rights and obligations will exist when it comes to data ownership too. Much of this will be governed by law, and you can set up all this as agreements in the platform, and when you do that, they will be impossible to break. You could, for example, stipulate that you'd have to share your healthcare data between all publicly funded healthcare providers or some other kind of legislation. All this legislation is not in place today, of course, because there is no platform like this today. And you can't legislate about things that don't exist, or you shouldn't. So it will have to be part of the Origo program, parallel to technical development, to have a look at the legal framework as well. Now, remember that standardization organization? This organization might use an Origo node as well, but their system won't be an EMR system, of course, but some concept definition service. And now they can describe this terminology standard in the Origo meta ontology. And when they do that, it will, if they allow it by consent, be immediately available for all users of the platform globally, including updates, of course. A very much simplified way of disseminating a standard and making sure it's updated out there. Now, some more about these concept definitions. Actually, as I said, anyone can create a new concept definition here. And when you do that, you will start by already existing concepts and make specializations or combinations of them, or create completely new ones. Now, suppose you work in this hospital here and you're not happy with just recording diabetes type 1 and 2. You've learned about these subtypes 1 alpha, beta and gamma. Then at your local hospital you will define these concepts as subtypes of the already defined ones and start recording this data about your patients in the Origo platform. And in this other hospital where they just record and display type 1 and 2 in their system, they will still be able to see that the patient has diabetes type 1 because 1 alpha is just a subtype of type 1. So interoperability will not break down due to different levels of granularity here. And then a couple of months later, when these guys too hear about these subtypes and want to start recording them about their patient, they will find that they are already defined in the platform, so they can just use these existing definitions. It's interoperability made easy too, and expansion of a standard without any lag, minimizing the need for ad hoc solutions. And this is important when it comes to research data, because in clinical research you wouldn't even dream of recording your primary data in the EMR system normally. You'd use some other system or just an Excel spreadsheet. But with the Origo platform you could easily use an Origo node to completely describe and store your primary data, including the process to obtain them. And then this data could be of use to other researchers as well if you and the patient consents to this, perhaps after you've published, of course. Also, the parameters you recorded about your patient could be visible in the care situation by the EMR system, if there's consent for this. And conversely, you might do research on clinical data from the care situation or data recorded by the patient in some health app, if that app uses the Origo platform for data storage, provided again that there is consent. And providing a means for a patient to consent to and share their data like this will be a game changer for research. And in the case of a new disease like this COVID-19, again, such availability of data would have given us so much knowledge that we are literally desperate for today, treating our patients or trying to figure out the best strategy for prevention. Once the Origo platform is in place and people start using it in society, we think the growth will be very rapid, a bit like Wikipedia, because when every user can define concepts, the ontologies will expand from below to, so to speak, in collaboration with everyone. And it will be easier and easier to start using the platform because the concepts you need will probably already be defined and ready to use. But there is an obvious question here, of course. If everyone is allowed to create concept definitions, how can you prevent this from turning into complete chaos? Well, when you do something in the Origo platform, you will always be logged into the platform with your unique digital identity, of course, but also always in a specified role. The most basic role is, of course, as a private individual, but when logged in at work, you will take on the role given to you by your employer. And everything that's done in the platform will be logged as to who did it and in what role, in what capacity. And in the case of this hospital here, when they wanted to start recording the new subtypes of diabetes and found them already defined in the platform, they of course used a filter when they looked for definitions. A filter like, for example, only concept definitions endorsed by at least one medical informatics specialist at some university hospital in Sweden, or some other filter they might create and apply. So they won't see chaos, they would see more something like this. So there might be lots of strange things going on in the Origo platform. People defining concepts for various needs they might have, but in normal use you would never see any of that. And here too there's a parallel to natural language, where anyone can state anything, but you won't be listening to people you don't trust. But the uncertainty of natural language does not carry over in this analogy. In the Origo platform there's always absolute transparency, so you can see who stated something, in what role, how many others that agree, in what roles, and so on. So if you run into a definition of the Earth as a flat disk, you would be able to see that there's not very many people agreeing and not a single of them an astronomer. So that is the Origo platform, and we're almost done now. A brief summary. Most basically, if you got a traditional system, you can simply export all the system's data or some of it to an Origo node without data loss, including any metadata. And then the patient, being the data owner, will access this data in her Origo node. So this will be an easy way to satisfy that part of GDPR. Also, she will be able to give consent to others to use her data, for example, another caregiver or a researcher, providing interoperability and availability of data on her own terms here. And this data flow can go in both directions, of course, in real time if you want. So in most cases it will be cheaper, easier and better for a system to use an Origo node for all its data storage, and a strategic choice for the organization as well, for future change of systems. This will of course boost innovation and competition between system developers as well. And because any process can be described in the Origo platform as executable code there, any algorithm can be set up to run completely within the Origo platform with no data exposed to the outside. This includes artificial intelligence algorithms, of course. And in fact, any IT system can be realized as a service within the Origo platform using the UX generator of the Origo node. So the system logic moves down to the Origo node, and you will end up with this. A few words about security. Origo nodes will be distributed as binary signed compiled code, which ensures that only code that's verified to the single byte is accepted to be a node in the network. All code will be open source, so users will be able to inspect, trust and identify problems and take part in improvements. Authentication when you log in will accept certified and trustworthy external services, where Bank ID in Sweden is one example, but there are others here, of course. All processing of data and communication between nodes will be protected by a firewall. Encryption keys will be confined to the inside of the firewall and never exposed to anyone. The encryption methods and signing procedures of the nodes will constantly be updated over time to ensure best practice, and the structures inside the platform are and will be developed to ensure security and personal integrity by design. When exporting data from the platform, all external identifiers will be encrypted specifically for the role identity of the user receiving the data, which makes it technically very difficult to combine any exported data. However, best levels of access and functionality for apps and systems will be for those apps running completely inside the platform. But probably the most important part of security on the practical level is that all processing and distribution of data will be completely transparent to the owner of the data, the person that the data is about. And this will also build trust. Which leads us to the governance of the Origo platform. That has to be on a non-profit basis, because trust in the platform is absolutely necessary for it to work as intended. So a non-profit organization will be set up, and this organization will take over all IP rights to the code once development of the platform is done. This organization will then be responsible for future development and optimization of the platform too. It must be independent of any private company, of course, but also of any state, because you never know what will happen in the future. Any democratic society can turn into a totalitarian one, and then all this sensitive data could be used for not so nice purposes. So the first priority of this organization has to be to guarantee security and integrity of the individual. Nothing will be more important. And it doesn't have to start big, but the constitution of this organization must be done in such a way that it can grow to be powerful enough to handle agreements between states, multinational companies, and to sustain great external pressure. There's much more to be said here, of course, and we have done a great deal of thinking, but I'll leave this to another presentation. So, for now, thanks for listening, and don't hesitate to make contact if you want. Thank you.